This tiny little moon, 500 kilometers in diameter, has proved that it can surprise everybody. Water vapor plumes with organic material coming out of this tiny little moon, who would have thought? I get asked whether Enceladus is my favorite moon, and at the moment it is, partly based on the observations that my team made and the discovery that we made at Enceladus. So the Cassini mission was the first spacecraft mission to orbit around Saturn and its moons. It was also the first mission to taste what was in an extraterrestrial ocean. The mission kept being extended and extended, and so in the end the mission lasted for 13 years. The discoveries were pretty radical. We were flabbergasted, to be frank. I think for me the most surprising discovery that was made was this water vapor plume at Enceladus, which we then followed up with discoveries about a liquid water ocean, under the surface a heat source, organic material. I've now given away all the secrets. My team and I changed the course of the mission because this was a team effort. So we had 3 flybys of Enceladus, and 2 of these flybys were quite distant flybys. In the data that my instrument took, so data from the magnetic field in the environment of Enceladus, we saw some strange signatures that we weren't expecting to see. And what those signatures were telling us was almost as if Enceladus was a bigger obstacle, a bigger body than it looked. We thought maybe we hadn't got the trajectory of the spacecraft back properly, so maybe we were seeing an artifact in the data. But the fact that we saw it on 2 separate flybys meant that we said, okay, we thought we were seeing something. So I actually traveled out to the Jet Propulsion Lab, and I was planning to make a presentation to the project, because what I wanted to do was I wanted to persuade them that we thought we were seeing this really strange atmospheric signature, and that it would be really good to go close on the 3rd flyby. And I was really nervous, because if the flyby changed, that meant all of the plans that we had made for the last 6.5 years would have to be changed, and some instruments would not take the data that they'd planned to. But the possibility that we would discover this water vapor atmosphere of Enceladus was exciting enough that the majority of people decided it was worth a go. It was extremely nerve-wracking waiting for that 3rd flyby. So, I'd essentially put my and my team's reputation on the line. And so I must confess, the 2 or 3 nights before the flyby, I didn't sleep very well. I tossed and turned a lot. Because if they hadn't found anything, no one would ever have believed anything I said again. Every once in a while you have to be brave and you have to say that you think you're seeing something, but luckily they found something. When we had that 3rd flyby, what we found was, instead of there being an atmosphere covering the entire surface, there was simply an outgassing of water vapor from the South Pole. In addition to that, because we went so close, all of the other instruments were able to take fantastic data sets as well. And what we found is there were cracks at the South Pole through which this water vapor was escaping. There was an internal heat source. There was organic material. And so that meant we had 3 of the 4 things for potential habitability to form. You need a heat source, you need liquid water, you need organic material, and then you need those first 3 things to be stable enough over a long enough period of time that something can actually happen. So that's when there was a real focus on Enceladus for potentially being a place where life or habitability might have been there in the past or might be able to form in the future. The coming together of all of the Enceladus data and the discoveries that were made underpins what I think is one of the most important discoveries that has been made in planetary science in the last 30 years. And that is that you don't need to look close to the sun to find liquid water. You can be quite far from the sun, but you can find liquid water. It's just not on the surface, it's underneath the surface. And so that's been almost been a sea change in planetary science. We now have a much better understanding about Enceladus and its internal structure. So we have a global liquid water ocean underneath the surface of Enceladus, and the surface is made up mainly of water ice. biggest unanswered questions for Enceladus are, why is there only a water vapor plume at the South Pole? We still don't quite understand why there's a heat source, because the fact remains that it was formed billions of years ago. Because it's so small, it should have cooled down. And so we think it might be linked to its orbit around Saturn. So if the orbit around the moon is not completely circular, then on some parts of the orbit it's closer to the planet than on others. And when that happens, tidal forces keep the interior warm. I think Enceladus will always be memorable for me, because in some ways it was my way of becoming confident in my ability to persuade people, but also confident in my team and what we were able to do with the data. That's probably why it's my favorite moon. Depending on what we discover at Ganymede, it might move slightly down my list. For me, it was almost a coming of age for my team, but also for the instrument. You know, people say to me, why do you explore planets? And for me, we are explorers. Humankind have always been explorers. When we didn't know much about the Earth, people would take ships and go to what some people said was the edge of the Earth, and they were scared they're going to fall off. For me, exploring planets is part of that exploration. It's what we do. My first view of Saturn actually was through a telescope that my dad built. I saw Saturn and its rings. Didn't see any of the moons because Saturn is so far away, but we were able to see the rings clearly, and we also saw Jupiter and some of its moons as well. So I never thought back when I was a child that I'd end up doing what I do today. I will never forget Enceladus. In planetary science, it will always be an important thing, and it will be an example that people refer to in the future as well.
Who owns Mars? It's a surprisingly big problem. With the USA and China planning to send humans by the 2030s, and with private company SpaceX potentially sending them by 2026, it's gonna get pretty crowded up there. You can even go online and buy a bit of Mars yourself. I've got mine. So who owns what up there? And what happens if things get nasty? I think we're gonna need a space lawyer.
It's time to explore the unexplored.
Space law sounds like a fantasy job, but it does kind of make sense. Surely there must be some kind of rules and regulations. Well, yes, and it started in 1957. The US and the Soviets are in the midst of a Cold War. They're sworn ideological enemies. Suddenly, the Soviets launch Sputnik, the first ever human activity in outer space. It flies around the Earth a few times, including directly over the US. And that raised a whole bunch of new questions. If an enemy vehicle enters your airspace, then you can shoot it down. But suddenly people had to think about, where does airspace end and space begin? The prospect of war in space was so frightening, they decided to keep the war on terra firma. To the surprise of the rest of the world, they joined together and drafted the Outer Space Treaty. Finally, it's over to the space lawyer.
The most fundamental baseline principle is found in Articles 1 and 2 combined, which basically makes outer space into a kind of a global commons, an international area, legally very similar to the high seas, and no single state can act as if outer space or part of the outer space or even part of the moon is part of their national territory. It's basically open for all states, and freedom for states to be active there is the bottom line. The drafters of the Outer Space Treaty were basically concerned with two elements, if you will. One was the military use of outer space, and then a secondary subsidiary level about science. The treaty didn't really discuss things which we are confronted with today as questions, at least theoretically, like the settlement on the moon or human settlements on Mars.
So it's good that states are free to use space, even if they weren't thinking about settlement. But that wasn't the only thing they weren't thinking about in 1957. The treaty only refers to political states. It doesn't even mention private companies. So does that mean that the billionaires of the world are exempt from the treaty?
One of the clear drawbacks looking back at the Outer Space Treaty was the absence of any detailed reference to the private sector. So what you see in the Outer Space Treaty is only one almost fleeting reference to the private sector in the guise of what they call non-governmental entities. But at the same time, it made sure that the state, in this case the United States or any other state, where those activities belonged to, was the one being responsible. And then Article 7 followed that up with also liability. So not only you as the United States will be responsible for them, for whatever they do, and you will be liable for any damage they cause by doing that. So the United States cannot dodge any international responsibility just because SpaceX or Virgin Galactic or Blue Origin does something in outer space.
Okay, so I get that ultimately states are responsible for what private entities do in space, how they operate and any damages. But what about the use of land on Mars? We're planning on building habitats and living on Mars. Is that even allowed?
So we have to make a very fundamental and important distinction between, on the one hand, the prohibition for any state to own part of Mars. On the other hand, the freedom of outer space activity, which is the other part of the global commons thing, also means the freedom of simply establishing a habitat, putting space objects there, which then serve as houses, or probably even excavate minerals locally and build a habitat from those minerals. That all is in principle, again, allowed. And of course, there is a tension between those two, because it is one thing to be allowed to land somewhere, to put people down somewhere, maybe to have them live there for 25 or 30 years. But at what point in time should we say, wait a minute, now we are moving to something which looks too much like a real colony, which is prohibited by the Outer Space Treaty? But again, that question has not been solved yet.
But it's not like here on Earth, where if you break a treaty, we can physically take action. Mars is over 300 million kilometers away. So if the USA or Russia or China or a private company starts breaking the rules up there, wouldn't it be pretty hard to stop them?
Next question is then, of course, what happens if a private entity disregards the international rules of space law? Well, if that happens, then of course the first line is that the operator who goes beyond the terms of the license will be held criminally liable under the laws of his own country. It becomes a little bit more complicated at the second level when we go to the international arena. Either these states have to agree to a tribunal, or they have to sort things out on a diplomatic level. And of course, then the reality of the international community kicks in, that the bigger you are as a state, the more you might get away with.
These are all crazy scenarios that could arise in the future. And talking of the future, many people see Mars as a future second home for humanity. But how would our laws on Earth work in space? And if no country is allowed to claim sovereignty over celestial bodies, then how will it be governed if there are communities and multiple generations of Martian people?
But of course, at some point in time, certainly when they start living there, knowing that they will never return to Earth, when they probably get babies there who have never been on Earth for any part of their life, there will be a tendency for those quote-unquote colonies, I prefer to use the word settlements actually, to say, well, we don't want to be ruled by this earthbound state anymore, because they have no idea what it means to live on Mars and to be safe on Mars. So we want to create our own legal regime, and sooner or later that may actually become, we want to create our own state. I often compare this with the Pilgrim Fathers who went to North America, and then after a number of years said, well, why are we still paying taxes to the British King in faraway London? So it took a war of independence before the United Kingdom finally accepted, okay, let them be on themselves, let them be their own state. I just hope that when that happens in space, we are more peaceful as terrestrial states in allowing those to go out on their own. But that's still decades away, if not much further.
If my first chat with a space lawyer has taught me anything, it is that there is still a lot of grey area in space law. If we want humans to play nice on Mars, then we're going to have to answer a lot of these unresolved questions. And if you're silly enough to have fallen for one of those bogus websites that claims that you can buy a piece of land on Mars, well,
the paper is just worth the paper it's written on, and it doesn't give you any title. Don't expect to reap any benefits from it.
We're used to seeing NASA fire up its rockets and launch billions of dollars of equipment into space. But what happens when it messes up?
The Hubble Space Telescope project has suffered yet another setback.
And how do you fix a billion-dollar mistake up in space?
I did not have a line item that says NASA put wrong mirror in telescope.
With engineers needing to fix it not once, but twice.
So the summer 2021 event was a pretty intense anomaly.
This is the story of how the Hubble Space Telescope nearly destroyed NASA's reputation, and the retired engineer that helped bring the telescope back from the brink both times.
When I received the call, I was honored that they would think of me to try and help them resolve this.
This is electrical engineer Ron Barish.
I started working on Hubble in 1987, approximately 2 years before launch.
Hubble was one of the most ambitious space projects the world had ever seen. NASA had spent hundreds of millions designing a massive mirror in the telescope to get the sharpest pictures of the universe ever seen. Expectations were high. It promised to catapult space science into a radical new era, and all eyes were on it.
And liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
It was very exciting to watch the launch.
You have a go to open the doors.
And even more exciting to verify that our system was functioning flawlessly when it was turned on in orbit. Very exciting.
NASA was quick to champion it as the greatest advance in astronomy since Galileo. But then disaster struck.
The Hubble Space Telescope project has suffered yet another setback. Engineers have discovered that the giant telescope has a warped mirror, which means the images sent back to NASA are distorted. The pictures are little better than those from ground-based telescopes.
We found out that there was distortion in the image. Well, the images I saw were blurry. They called it spherical aberration.
When light enters the telescope, it's reflected first by a large 8-foot mirror onto a smaller secondary mirror, which concentrates the light onto the cameras. If either mirror is slightly out of true, the picture becomes distorted.
And that's exactly what had happened. The mirror hadn't been tested with the rest of Hubble. Had it been tested, the scientists would have seen that the mirror was ground incorrectly by just 1/50th of a human hair. Tiny, but enough to ruin everything.
Everyone on the project was very disappointed, and it was an embarrassment that we had spent so much time on the program and that there was a significant flaw. The news was not very kind to the project.
For the American taxpayer, they're not going to be happy.
Well, look, you launched this $2 billion white elephant. What are you going to do?
And the bad news kept coming, as NASA's reputation received blow after blow after blow.
Matter of fact, my sister said to me, you worked on Hubble, that's an embarrassment to the United States.
But despite the setback, there were still some that had hope for Hubble.
So do not write off the Hubble telescope. It merely means it's not going to be quite so good as expected until the repairs are carried out.
Replacing the mirror wasn't practical. So instead, Ron and the rest of the team created an instrument called CoStar, which would act almost like a pair of glasses, redirecting the light to account for the flaw in the mirror.
My job was to provide an electronics interface box called the Remote Interface Unit, CoStar.
3 years after Hubble's embarrassing start, they finally had the parts needed to fix the broken Hubble Space Telescope. All that was needed now was a team of astronauts bold enough and daring enough to attempt a mission of this magnitude.
There weren't very many of us in the office at that time who had done spacewalks, and so that's how I got kind of a quick turnaround from one flight to the next.
You know, in all the fares, the hundreds and hundreds of fares I came up with that I had to accommodate, I did not have a line item that says NASA put wrong mirror in telescope.
Catherine Thornton and Story Musgrave were two of the astronauts that were selected for the mission, and in 1993, they set off. The world held its breath as the astronauts carried out 5 back-to-back spacewalks in an attempt to bring Hubble back from the brink.
The first spacewalk on Hubble, did the dance. When the music starts, what you gonna do? Well, you got a power tool and you unbolt the thing, you undo the connection, zip, zip, stick it in the box. Hang it over there, get the new one out. Slide the new one in. It's fingertips, baby, fingertips.
That's what's so awesome about Hubble. It's almost like plug and play. We installed CoStar We installed a coprocessor on the computer to give it more memory, added a new magnetometer, and other cats and dogs, as we called it.
It is easy. You've got to make it easy.
Around the world, astronomers anxiously awaited the first pictures from Hubble's new camera. On the 18th of December, 1993, the results came in.
Hey!
Right there!
Oh! Get it!
When an image hit the monitor, oh, God, the whole room, everyone screamed. It just got it fixed.
Okay. That is better than any deconvolution you've ever seen. Those are actually stars.
I think you got it.
Yeah.
Yep.
Sir. It may be a little premature, but I'll shake your hand.
When the images first came back and I saw them, made me feel proud that I was part of that mission and that we had brought the telescope back to what it was supposed to be. As a matter of fact, my understanding is the images were clearer than what they had ever expected.
To the relief of Ron, NASA, and the entire world, Hubble was finally fixed, and it immediately began to deliver on its original promise, allowing us to see the universe in ways we could previously only dream about. Hubble was only supposed to last 15 years. Instead, it continued to make groundbreaking discoveries for more than 30. But then in 2021, it suddenly shut down. And the team at NASA once again had to fight for Hubble's survival.
So the summer 2021 event was a pretty intense anomaly, probably one of the more dramatic ones that we've had.
Nzinga Toll is the anomaly response manager for Hubble, and it was her job to figure out why Hubble's computer had shut down and ultimately find a way to get it back up and running. But that was far easier said than done. So Nzinga had to think outside the box.
After the first few days, and it wasn't immediately apparent that we could get a path forward to resume science, we knew we'd have to pull in a lot more folks.
With Hubble still showing no signs of life, Nzinga knew she needed some very niche expertise to try and help fix Hubble. So she called upon Hubble's original architects to come back and get stuck in.
When I received the call, I was honored that they would think of me to try and help them resolve this. Anytime you work on a system like this, it's part of you. It's if there's ever a problem with a spacecraft in orbit, everyone jumps in and works on it, even if you're retired. A lot of people were concerned that we would not be able to fix the Hubble. It was very stressful. The last thing I wanted was to have the system that I spent 18 years of my life on to be the cause of the end of the mission. And so I was under a lot of stress.
But undeterred by the challenge, the team set to work to identify what went wrong and get Hubble back online.
The telescope was down for approximately 4 weeks.
I think the first couple of weeks was probably the most frustrating and the most anxiety producing.
We put together what's known as a fishbone diagram. Everything that could possibly cause the problem was written down, and we eliminated them one by one until we zeroed in on the exact cause. It was amazing how everything came back to me.
On July 15th, Nzinga and her team successfully powered up the backup computer on board Hubble. And over the next few days, the team gradually brought the science instruments back online.
Once we realized that we had solved the problem and the telescope was back up and running, it was quite a relief.
Mainly relief. Mainly a lot of relief.
How did it feel compared to 93?
In my case, it was even better. This was my system that had stopped, that had halted the telescope, and to be able to get it back up and running was very proud. I was very proud when, after the first servicing mission, that we got the telescope up and running, but this was more personal. If another problem comes up, I'd be very proud to work on with this team again to resolve any future issues.
It would be an honor and a privilege for for me to be called back to support Hubble at any point in time. I will always be a Hubble hugger.
Early in its history, radioactive elements in its interior would have provided heat that melted the liquid water that's currently ice. And so we think that during the early portions of Ceres' history, it had a global ocean.
In infancy, Ceres was well on its way to becoming a fully fledged world. The water that now lies frozen within its interior was once liquid. Protected beneath a thin layer of ice, ancient Ceres is covered by a deep saltwater ocean. But then, something happens to cut its development short. As the young Jupiter circles the sun, it clears a path through the gas cloud that envelops the early solar system. But that process causes it to do something alarming. Jupiter begins to spiral inwards, plowing straight through the region of space that would become the asteroid belt.
When the young Jupiter moves through the primordial asteroid belt, things get scattered around, things get gravitationally deflected, and as a consequence of all of this gravitational interaction, more than 99% of the original mass that was there is basically now gone.
The asteroid belt has been disrupted over time by the movement of the giant planets. And this has acted to throw material from the asteroid belt out of the asteroid belt into the outer solar system.
These protoplanetary cores, like Ceres, were never able to graduate to full-fledged planets because there was just not enough material in the orbital neighborhood.
When Jupiter passed through the primordial asteroid belt, it starved Ceres of material, halting its growth. And the dwarf planet was condemned to live out its life as a cold, barren rock. But Ceres isn't the only world in our solar system whose development was cut short. Mars would suffer a similar fate at the hands of Jupiter. After marauding through what would become the asteroid belt, Jupiter enters the region of space where Mars is forming. Continuing its journey, spiraling towards the sun. As Jupiter bulldozes inwards, its immense gravity scatters material in all directions. Some is sent careering into the sun. The sun's outer corona burns at a scorching 1 million degrees, releasing a barrage of charged particles that travel at around 400 kilometers per second. The solar wind. This onslaught would strip away our atmosphere, but for the powerful force that protects us, the Earth's magnetic field.
Solar wind is this stream of charged particles that come streaming out from the sun. And at Earth, which has a powerful magnetic field, when those charged particles begin to get close to Earth, they get diverted around Earth by interactions with that magnetic field.
That protection keeps solar wind and other ionizing radiation off of the surface. So on Earth, where we have this really great magnetic field, we are nice, safe, and sound inside the shell of that, protected from all that radiation.
The magnetic field of Earth effectively forms a protective bubble around the Earth's atmosphere.
And when the sun dips below the horizon, there are times when Earth's protective force field is visible. The aurora is a stunning display of Earth's magnetic field in action. It's best seen at the poles, but across Earth, it's protecting our atmosphere and all life on our planet. This vital protective shield is generated deep within.
The way a magnetic field is generated inside a planet is when you have convective motion in a fluid that is capable of conducting electricity. And in the Earth, that electrically conducting fluid is liquid iron. And the molten portion of the Earth's core is a place where these motions take place, and it can set up a magnetic field.
Just like Earth, Mars once had a molten metallic core, generating a magnetic field around the planet. Auroras danced above Mars's poles, protecting its atmosphere and seas below. But the field didn't last.
In the oldest rocks on Mars, you see evidence of a once powerful magnetic field. You get to the younger rocks, the rocks that are 3 billion, 2 billion, 1 billion years old, no evidence of a magnetic field whatsoever, and there is no intrinsic magnetic field on Mars today.
500 million years after it formed, Mars's magnetic field dies out. The bright auroras above its poles slowly fade away as the shield that protects the planet shuts down for good.
Once it stops, then what happens is all the atmospheric components, things like hydrogen and oxygen that make up water, they get stripped away because you don't have the shield, the magnetic shield anymore, so the high energy particles that come in from the sun and from outer space, they begin to strip away the components that make up water.
Without its magnetic field to protect it, Mars's atmosphere and then water slip away into space. So why did Mars lose its protective shield? What happened deep beneath its surface that stopped Mars from developing like Earth? The answer lies at the beginning of Mars's story, at its very creation. $4.6 billion years ago, when the planets were forming from the dust cloud circling the sun. Early differences between Mars and Earth set the young planets on very different paths. Mars forms further from the sun, where crucially, there is less rocky material to build a planet.
Mars is different because it's not just further out, it's actually much smaller. If a planet gets to be too small, it just freezes all the way through.
Mars is just half the diameter of Earth, meaning its core cooled more quickly. And so it lost the heat that powered the dynamo that generated its protective shield. Mars's small size, condemning the planet to die.
The universe is not what you think it is. That's because what you can see is only a tiny fraction of it.
We have no idea what 95% of the universe is. It hardly seems that we understand everything.
Maybe we're just going to have to scratch our heads and start all over again.
It begs the question, why is 95% of the universe missing? For decades, physicists have been trying to find this elusive, undetected part of our universe. And in the beginning, we just had a name for it: dark matter. So what is dark matter?
Sounds exotic, but it doesn't have to be. There's a lot of dark things out there in the universe. Until I shine my light at these bottles, I can't see them. Dark matter could just be ordinary stuff that you can't see.
Now, what we do know about dark matter is that it's matter that doesn't interact with light, so we can't see it. But we know it's there because of its effects due to gravity, because of the way that stars orbit the centers of galaxies. The stars on the edge move a lot faster than they should, so there has to be more matter out there on the outskirts.
Well, there's an alternative idea for what the dark matter could be. And so what we think it is that it's some new kind of fundamental particle. Not neutrons, not protons, not ordinary atomic stuff, but something entirely new. And these particles are everywhere in the universe. They're flying around in our galaxy. They're in this room. Actually, there'd be billions going through you every second. You don't notice, but they're there.
So this invisible matter that dictates how our universe works is known by particle physicists as WIMPs, weakly interacting massive particles. If we can't see them, how do we find them? Part of the problem is that here on Earth, we're searching through a relative swamp of ordinary matter that we can see, which kind of blocks our view of the stuff that we can't see.
If you were to try to build one of these experiments in a laboratory on the surface of the Earth, then your signal would be completely swamped by cosmic rays. They would just ruin your attempt to do the experiment because the count rate from the cosmic rays would be so high that you'd never be able to see the WIMPs.
And that's why scientists are doing something that at first might seem pretty strange. They're going underground and searching in the dark.
After walking a mile underground like this, you have to wonder about the fact that we may be looking in the wrong place. This is the inner vessel of Pico 2L, we call this project, and it goes inside that big recompression chamber. We put a liquid in there, what we call a superheated liquid. It makes it sensitive to radiation. So when particles strike the liquid that goes in there normally, it's now empty, they produce bubbles. Piezoelectric sensors, they're very sophisticated microphones. And through sound, we're actually able to differentiate between different types of particles as well.
What sound would dark matter make?
It's actually very soft. It's not the loudest.
But of course, there's a chance that looking for dark matter in this way, by essentially listening to it to see if it makes an appearance, might might never be possible.
You do your job the best you can, and then you hope for the best, but nobody knows if there's WIMPs out there or not. We're trying.
Now, other scientists are searching for this mysterious dark matter by using the world's largest physics experiment at CERN in Switzerland, the Large Hadron Collider. They're not listening out for it, they're attempting to make some from scratch. What they're doing is smashing together known particles at huge speeds to create huge energies in these impacts that might just spew off some particles of dark matter.
When the protons collide, most of the time the particles they produce, nearly always some new particles are created, but they tend to be low mass particles. But sometimes, very rarely, you produce these much more massive particles, and these are the guys that we're really looking for.
So the search for dark matter continues in underground labs and at CERN, and also by observing the night sky. And scientists believe they're getting closer to discovering what it's made of. But will we ever find it?
You have to accept the evidence. And if it turns out that I wasted my life working on the wrong hypothesis, so be it. What I really want to know is, what is the universe made of?
I can really see it as being a particle in nature, and I'm really driven, as we all are driven here, to try and find it.
And if you don't?
We will dust ourselves off and move on.
Whatever they do find will surely change the laws of physics as we know them. With scientists pushing new technologies and the boundaries of our knowledge, what's more, we've now realized that dark matter is only just the start of the story.
So 15 years ago, some astronomers observing distant supernova saw that the distance to those supernovae was larger than they expected. And so the only way that they could understand that was to have a universe that started accelerating 3 billion years ago. And whether that carries on accelerating or not, we don't know. But what we do know is that there has to be another component to the universe, which we call this dark energy.
But you don't know what it is?
No idea. Not at all.
No one knows what it is?
No one. No one. There are more theories than there are theoreticians.
So whilst dark matter might make up 25% of the unknown stuff in the universe, there's this whole other whopping 70% made up of something called dark energy. We know even less about dark energy. It's so weird and so unknown to us that we're actually going to need a whole other video to find out about it.
The question we all want to know is, are we alone? And now we have eyes on the ground. Perseverance is ready to answer that question for us.
Touchdown confirmed. Perseverance safely.
For the last 4 years, I've been recreating the surface of Mars in my lab at the University of Oxford. What I've most been interested in is whether I could recreate lakes and other liquid water environments that might have existed on the surface of Mars about 3.5 billion years ago. Where it gets really interesting is that now NASA has landed a rover, the Perseverance rover, right in a crater that might have once hosted a lake. Although there's no water on the surface of Mars today, there is inescapable evidence that it was once present. When you look at it from space, you'll see certain features that jump out at you as being quite similar to those we have on Earth. You'll see sweeping valleys that look like they were carved from liquid water.
These are actually pebbles that are a few centimeters in diameter. What you can see when you look at the pebble outlines is that they have rounded shapes. So they've been basically rounded during a transport process. And they're too large to have been moved and rounded by wind processes. And so the only way we can actually get this rounding is by water flow.
You'll see gigantic canyons. This one here is the Valles Marineris. And this thing would stretch from Los Angeles to New York. This thing is truly colossal.
And I remember when this image first came up and we were all huddled around a giant screen looking at this. It actually took us a while to really hit home oh gosh, actually this is the first evidence from on the ground of water flow on Mars.
We see great big ice caps at the poles, much like we do on Earth as well. We see signs from space that are immediately recognizable as great big channels, enormous floodplains, the largest in the solar system, that would have excoriated their way across plains as large as the continent of North America. We see chemical signatures, we see minerals that have water locked in their structures that could have only formed when that water was freely available. And we also see both of these coming together in the form of certain features that we know from studying them on Earth only form where there's bodies of water. Where Perseverance is sat is a crater called Jezero, and why Jezero crater was selected is that it combines these two key indicators of water in one site. And how deltas form is where you have a river flowing across the surface of a planet, and in its water it's containing all kinds of churned up sediments. And then as soon as that river reaches an open body of water, like a lake or an ocean, it dumps all of that sediment load. Why the Perseverance mission is so exciting to me is that for the past 4 years, it was those carbonates that are found in its delta that I was trying to recreate in my lab. Perseverance has been in the making for a very long time, and it's a roving scientific suite of instruments. It's a moving laboratory, and it's absolutely incredible the things it can do. So to finally get to hear the sounds of grains of sand being turned over, and the sounds of that very thin atmosphere being blustered around in this crater, it's absolutely incredible. And the first times I saw the pictures from the surface, it was like being in Star Wars and learning about whole new places. I couldn't believe it, and here 5-6 years later I am with my PhD on the surface of Mars. I feel very, very fortunate.
Altimeter data confirm that Ingenuity has performed its first flight of a powered aircraft to another planet.
What's incredible about the little Ingenuity craft is that this is the first time anything has been airborne on another planet at all, not just Mars.
So the image we're looking at on the screen is the image from our onboard navigation camera showing us hovering above the surface of Mars. How incredible!
The idea is that it might be able to scout ahead to places of interest for future astronauts and look for any hazards. Perseverance has 4 main scientific goals. First is to search for habitable conditions. The second is it's interested in searching for biosignatures. The third mission goal is to harvest and then cache together samples of interest to return to Earth. The absolute dream is to one day have a sample of Martian soil returned from Jezero crater from those carbonates that you can see from orbit, and to compare that to the kinds of crystals that I was forming in my lab, and just see how similar are they, what do they look like. And the final goal of the Perseverance mission is to prepare for humans to come and live there one day. People who are fit, people who are top in their fields, people who are experts, people who have a spirit of adventure. But I would say most critically, you need people who have the right temperament.
Think about a mission to Mars. What is it? Is it outdoor stuff or is it confinement? And then I see somebody that says, I have a stamp collection, I do a lot of reading, I enjoy watching movies, and I'm thinking, that might be good for confinement.
Artemis is a key step in getting humans to Mars. Right now, launching humans from Earth is extremely expensive because we're just so heavy getting off this gigantic rock. Instead, if we can have a base set up on the moon, we can have supplies ready to go from there, manufactured on the moon, that can then be launched straight to Mars. And so this makes it cheaper and easier to be launching things not just to Mars, but perhaps around the solar system as well. Once you've got to Mars, there are a whole host of problems that you wouldn't even think about based on life on Earth.
So you need something to protect you from essentially exploding, or at least having your skin all stretched out and the blood boiling and getting the bends, things like that. The way spacesuits are designed now, they're mostly pressurized spacecraft. Essentially, they're almost like a mini spaceship.
Things like, how do you maintain water? How do you recycle your water supply? How do you recycle waste?
Here we are at the throne. Number 2, right here. It's pretty small, so you have to have pretty good aim.
How do you keep making the best of everything you've got without throwing things away? And they're all problems that we're going to have to overcome if we're ever going to be a spacefaring interplanetary species. I've had a very long time to think about whether I would go to Mars, and so I'm not being flippant when I say yes, absolutely. Would absolutely love to go. It would be the most fabulous adventure. There'd be so much to do and explore and so many questions, endless questions. So yes, absolutely.
Big Bang was not the moment of creation.
It was actually this. The cosmic dawn, the moment that the very first star in the universe was formed and started forging the materials that we need to make you, me, and everything around us. This is your origin story.
Several million years after the Big Bang, the universe was dark and boring, filled with cold hydrogen atoms floating through space. All the things we treasure did not exist.
The Big Bang created space and time and all of the essential ingredients, but it didn't create anything that was recognizable as our present-day universe. Instead, it left us with one of the most boring periods in the universe's history, the cosmic dark ages.
If you go back to this time of the dark ages, the universe looked completely different. If we had a human observer translated back in time, we would see a completely dark, boring, featureless universe. An utterly alien place, it would appear to us. It was a universe without any light. There were no stars, no galaxies.
Now, the transformation of our universe into one that we would recognize didn't start until the first stars were born.
The cosmic dawn would have been spectacular.
There was this magical, if you like, metaphysical moment.
It was the starting point that led to the appearance of life.
The moment of first light.
Let there be light.
The first stars are fundamental to how the universe evolved.
New galaxies were forming out of darkness. This age of enlightenment was a very dynamic period of time.
What we found is that in the early universe, stars are much more massive, maybe even 100 times more massive than the sun. That has dramatic consequences because massive stars have a very different life, a much more violent life than the kind of low-mass star that the sun is. They would be 20 times hotter, shining ultraviolet blue, 10 million times more luminous than the sun.
They're gonna live for a very short time, only a few million years. That's really nothing. We often say they're like the rock stars in the universe. They live fast and die young.
Stars were appearing and disappearing.
It's like fireworks. It's very dynamic.
It grew up exponentially. Very quickly, within tens of millions of years, there were plenty of stars filling up the universe. The cosmic dawn is the beginning of complexity in the universe that led to our existence.
So stars are essentially giant furnaces, right? They take the simplest element, hydrogen, and they transform it into the heavier elements needed for life. This is why stars are so important. They create the sugar, spice, and all things nice needed to make you, me, and the Powerpuff Girls.
For the first time, new elements are being made. They take hydrogen, turn it into helium. Helium gets combined to make carbon, and we go to oxygen and silicon.
The rocks that we see have been formed inside a stellar interior and then thrown back out into the universe. The gold and the silver and the rings on my finger, they've all been made in a supernova. There's no other place in the universe that you can create elements like that.
So it might sound like an internet meme, but it's true. We literally all are made of stardust. But we have astrophysicist Margaret Burbidge to thank for that. She actually managed to figure out what was going on inside stars. So far, so good, right? We've got this epic theory of creation that took billions of years just to get the ingredients for you and me. But how do we actually go about proving that that's what happened? So scientists are on the hunt for eyewitnesses, stars that could have been there at that first moment, that cosmic dawn. Luckily, astronomers on the search for ancient stars know what to look for. We know that they are much bluer than the stars of today. That's because ancient stars are made out of pure hydrogen, so they burn much more efficiently and therefore much hotter, which means they're blue. Think about like the flame on a hob or a Bunsen burner, which burns blue, compared to the flame of a candle or the dying embers of a fire, which burns orangey red. In 2013, Stephen Keller and his team found that needle in a haystack, an ancient star in our own Milky Way galaxy that provides valuable clues about what happened at the cosmic dawn.
At first we thought we must have done something wrong here, but we confirmed it the next night, and that's when things really got exciting. It's been around for 13.6 billion years. It's a very pristine star. It formed very early on in the history of the universe. In fact, what we're able to do with this star is, for the first time, say that there was only one star that preceded it.
So this is the purest star that we've ever found, making it the oldest star that we know of. But it's still only a second-generation star, not a first-generation star, the first to form in our universe. We need to find one of those. This is why astronomers are excited for the launch of the James Webb Space Telescope later this year, because it might just have a chance of spotting some of these first stars being born. So there was the Big Bang, and then 100 million years of nothing, and then there was the big switch, when the universe finally turned on the lights. The cosmic dawn. This finally gives us a scientific answer to one of the biggest questions that humanity has ever asked, one we've been searching for answers to for millennia. Where did all this come from? Well, it turns out that the device you're watching this on, the chair you're sat on, and even you yourself, well, all of the stuff that makes all that comes from stars.
We are all curious where we came from. If one opens the first chapter of Genesis in the Bible, the Old Testament, one finds a version of this story, how the universe started and how we humans came to live in it. Some bits of this story are right. There was a beginning in time. Light came into existence from darkness. Life was created. We are now at a special time that allows us to explore this question scientifically. We are able to peer deep into space and see those very early sources of light that tell us how we came into existence. And of course, with modern technology, we're hoping to get the story much more accurate.